Welcome to this lesson, the Introduction to Solidity Programming, presented by Coding Bootcamp. This is the Introduction to Ethereum. And we've covered this information, and we've covered our prerequisites. So Ethereum is an operating network. So if we think about an operating system, that is almost always a single node or single computer running different applications. Ethereum is a scaled up version of that. So Ethereum is an operating network running distributed applications. So distributed applications are written for the Ethereum blockchain or the Ethereum network, and they run on Ethereum in a similar way to how applications, typical standard applications, run on the operating system of a computer. And Ethereum's native token or cryptocurrency is called Ether. And here is the Ethereum logo. Before getting to Ethereum, let's just quickly review the basics of blockchain. So blockchain is a ledger, and it tracks ownerships of assets. Blockchains are scalable, and construction is unique and provides security and immutability. And until blockchain, transactions with few exceptions required a third party to act as a trusted intermediary. And that trusted party needs to get paid. Trusted third parties perform a service, and that service has a price. The involvement of the trusted third party also involves time. So when a typical transaction with a bank is completed, it is pending for a certain period of time. Maybe it's sometimes days. With a blockchain, it can be minutes that a transaction is pending for. So they are confirmed quite quickly and with a much, much lower cost. The first assets on a blockchain were cryptocurrency. And if we look back at Bitcoin, that again is that application that runs on the blockchain. It's in a similar way that Google and Yahoo are applications that run on the internet. On a blockchain network, users or transactors conduct traditional commerce, agree on prices, buying and selling. On the Bitcoin network, users send and receive the digital Bitcoins between one another. And the transactions, again, are permanently entered and time-stamped into the Bitcoin blockchain. As a result of the success of Bitcoin, blockchains have progressed. Till today, we have our second generation blockchains. So second generation blockchains not only manage a native token or the exchange of value, but also they can manage any type of asset. So it does not have to be the native token. We could have an automobile, a house. And the way we do that is by defining an asset and taking action on it with a smart contract. And the emergence of the second generation blockchains have caused us to think about how assets are traded on a blockchain. So Ethereum and other second generation blockchains have made it possible to exchange any type of asset on the blockchain. An example of important information is blockchain voting, right? So we can do important information can be an asset. And we can also describe real world assets as well. So blockchains such as Ethereum make it possible to model assets on a blockchain. So if we wanted to transact on an automobile, we could have the VIN or the vehicle identification number as one asset, possibly the color, the year, the make of the car. So we are modeling that asset for a smart contract to conduct commerce on the blockchain. Assets generally come in two varieties, tangible assets and intangible assets. Tangible assets exist in the physical world, maybe gold, computer, a car, a building. Intangible assets could be a bond, an IOU, a patent, a copyright, or a trademark. It could be a music file as well. Both tangible and intangible assets can be transacted on blockchains like Ethereum. And an asset is an entity of value. Accountants say assets are entities that can result in positive cash inflows. Other assets, examples are money, cryptocurrency, property, and so on. Ethereum and other blockchains run on that distributed network, so like that operating network. Each computer on the network is a peer and has a full copy of the ledger with all of its data. So certainly on the Ethereum network, all nodes are identical. So there is only one node type on Ethereum, and each node has a full copy of the ledger. That's not true with blockchains such as Hyperledger or Corda. There are nodes actually specialize on those networks. This form of network always ensures the blockchain is up and running and is also less vulnerable to attack. So if we take a look here at different types of networks, we have the centralized network, which has one focal point, and all of the clients or all of the other nodes are communicating with the central focal point, and messages are relayed from the central focal point to the other nodes on the network. And then if we look at a scaled up version of that, we have a decentralized network where we don't have one central focal point, but several. So the central focal points can communicate, and then we have nodes that communicate with each of their own assigned focal point. So we have many focal points and then many nodes, and then the nodes are assigned to communicate with a single central focal point, and messages are relayed between the nodes and their own focal point and between the focal points. And with a distributed network, there are no focal points. Every node is a peer. And it's a peer-to-peer network, sometimes it's called. So every node is the same. So you can see here, if any of these nodes go offline, that node can be replaced by a different node until this node's able to come back online. So in summary, we talked about a little bit about the Ethereum structure. And again, a little bit more, we reviewed blockchain basics and blockchain architecture. So please take a look at the assessment and take a look at your learning materials for the answers. Again, number 1, number 2, and go all the way up to number 10. And again, look at your learning materials for additional resources. And also look back to coding boot camps for additional opportunities for training. In our next section, we're going to get our first look at Solidity and the Remix development environment. Thank you.